G'day everyone, my name is Jonah. Today we're just going to be taking a quick look at the MIPS assembler and particularly how it breaks down certain pseudo instructions into real instructions. So as we can see here, we've got our load immediate pseudo instruction. So what we want that to do is we want it to put this immediate here, OX 1, 2, 3, 4, 5, 6, 7, 8, into the register T0. Now our first question is, why does this have to be a pseudo instruction? Why can't it be a real instruction? Why can't this be a real MIPS32 instruction that actually executes on the chip? And the answer to that is that this immediate is 32 bits long. You can count the number of bytes. Each byte is a pair of hexadecimal digits. There's 8 to 4 bytes, 32 bits. You get the idea. But a MIPS instruction is 32 bits long, which means that it's not going to be big enough to contain this value. The value would fill up the entire instruction, all of the bits of our instruction. It's too big, so we need to break this up into at least 2 instructions. And what the MIPS assembler will do is it will split it into the following 2 instructions. And we'll just take a look at those now. So the first instruction is LUI, load upper immediate. And what that will do is, if we just take a look at T0 now, what it does is it puts the immediate, which is now, as you can see, this is a 16-bit immediate. It's the first 16 bits of our immediate here. It will put that into the upper 16 bits of our register, and it will fill the rest of the register with zeros. So after this operation, after this first operation, you can probably see for yourself, T0 is going to contain OX 1, 2, 3, 4 in the upper 16 bits, and it's going to contain zeros in the last 16 bits. And again, hopefully you're keeping up with translating between the number of hexadecimal digits, number of bits. 4 hexadecimal digits is 16 bits, and so on, and that's the same as 2 bytes, and so on. And then the next instruction is OR immediate. So that's gonna do the logical OR operation on this register with this value and store the result in this register. That's the standard MIPS kind of format. So after the second instruction, T0, this value, gets ORed with this immediate here, OX, and I'll 0 pad the front just so it's clear what we're doing. 0, 0, 0, 0, 5, 6, 7, 8. And the deal with OR is that if you OR any number with zeros, you just get the number you ORed with the zeros. Because if you had a 1 and a 0, then you get a 1, and if you had a 0 and 0, then you get 0. It's the same. So because we've got the zeros here and we've got the zeros here in the upper half, so you can think of maybe like one number stamping on top of the other number. That's not a bad way of looking at it. But as you can see, the result eventually, after the second operation, T0 is just going to contain OX 1, 2, 3, 4 in the upper half and 5, 6, 7, 8 in the lower half, which is exactly the same as what would happen if we executed this single instruction, which doesn't exist. But the idea is we're executing 2 instructions, 2 real instructions that perform this operation. So we're splitting, this is a programmer's convenience. These are the real instructions that actually do what this instruction theoretically, or I guess what the programmer wants it, what this instruction should do. Anyway, I hope that made sense. Best of luck in your labs and programming.